Hello friends. So today we are going to locate the center of rotation of a slip circle passing through its base. So far you have seen that if it is a two failure, how to locate the center of rotation. And I have already given you the complete information that from the directional angles given by Fellenius, you get the value of alpha 1 and alpha 2, that is the directional angles for given angle of the slope, angle beta. And therefore, it's very easy to locate the center of rotation if it is a toe failure. But the same principle doesn't hold good if it is going to be a base failure. And you know that base failure do take place if there is a softer ground below the slope, the base failure can take place. And the slope is quite gentle. So for that case, how to locate the center of rotation O for the slip circle passing through its base, what is known as base failure. So what is important here is unless you know the magnitude of this value EA, where EA equal to X, this value, you cannot draw a trial slip circle. To draw a slip circle, you need to know the value of X. And let's say AB is a slope as shown in this figure. So AB is the slope having height H. So here we can show the height. Let's say the height of the slope is capital H, which is known to you. So angle beta is also known to you. Height of the slope is known to you as H. And let's say the slope failure, the trial slip circle is going to extend up to depth D, which is known to you. So the depth of the trial slip circle is going to be up to D. So that's known to us. So what are the known? The known data are slope angle beta, the height of the slope H, and the depth to which this trial slip circle extends. That depth is called depth D. And in order to locate the center of rotation O, the conditions that must be fulfilled is number one, the trial slip circle must be tangent to the form base. So the trial slip circle, which is going below the 2, must be tangent to the form base. So here the slip circle is passing like this, and this becomes the form base. So that is shown over here by green line, hashed line. So the first condition that must be fulfilled is our slip circle must be tangent to the form base. And the second one, the center of rotation O will lie or lies on the vertical line passing through the midpoint of the slope. So AB is a slope, the midpoint is M. So M is the midpoint. So M is the midpoint of the slope AB, and this is the vertical. So O is going to lie on this vertical itself. The center of rotation O is going to lie on this. So how will you find it out? Because the depth is known, now H is known to you. Whenever you are going to have a trial slip circle, the form base is going to be tangent to this circle. So you know the form base at what depth it is going to penetrate. So D is known, the height of the slope is known, and angle beta is known. And therefore, you can first of all calculate the ratio of D by H. So the first thing that we need to do is calculate this complete depth D upon H, and this is called a factor known as depth factor, ND. This we call it depth factor. It's a factor. So we can calculate the depth factor very easily, and once you calculate the depth factor, you know the angle beta. So the slope angle beta is measured and is known. So what you know now is the depth factor, and also you know the slope angle. Once you know this, you can easily find out the value of x, that is EA. EA can be found out very easily, because you can make use of the chart given by Fellenius way back in 1927. Felenius gave the chart in the form of chart, how to find out this value of x. So x can be found out from his chart, provided you know the slope angle, 1, and you know the depth factor. So because you have fixed up the depth up to which this trial slip circle will penetrate. Hence, you know the depth factor, you know this. So the next part is to calculate, to find EA equal to x from the chart given by Felenius. So how will you do that? So on the x-axis you have the let's see how to do that. It is very simple to find out this value of x. X is from here to here is the value. EA equal to x. So you can find it out. So what you are going to have is on the x-axis you are going to have the slope angle, beta. So various slope angles you have, and on the y-axis you have got the depth factor ND, and then from the chart given by Fellenius you get a distance factor called Nx. So you will be getting from this chart for the given values of beta and given values of depth factor, you are going to get from the chart the distance factor. So what we are going to get is, now from the chart you will be getting the value of Nx, that is the distance factor. This distance factor is given as x divided by h. Therefore, from the chart we get the value of x. X becomes equal to distance factor Nx multiplied by h. Now h is known. This we have already obtained from the chart, and therefore we are in a position to find out this value of x. So what we know now is this point E is fixed. We know the value of x. So from this to A, you can measure this distance and fix up the point E. Now, you divide this AB such that M is the midpoint, so that AM equal to BM. So M becomes the midpoint, so this is the midpoint. Having got this midpoint, draw a vertical. Now, this point E is fixed. Now, taking OE as the radius, you can draw a trial slip circle. What is the condition? The condition is this slip circle must be tangent to this form base. This you must take care of. If it is not, you can take O little up or little down, so that whatever point you take it, and from there taking O as the radius, you will have to adjust the center of rotation little bit. You will have to take it up or you will have to take it down. You can move it on this vertical line passing through M midpoint, such that this trial slip circle is going to be tangent. It is going to be tangent to the form base. And then once you know this, you can locate the center of rotation. Once the center of rotation is located, you can draw the slip circle, and then the whole analysis can proceed. So here the importance is how to make use of the chart given by Fellenius. Felenius chart of 1927 is of great use, very important, because it gives you the distance factor, and once you know the distance factor, height being known to you, you can calculate the value of x, and therefore you can locate the center of rotation. Even in toe failure, you have seen that if this is the slope and there is a toe failure, and if this slope angle beta is greater than 53 degree, then you can find out the value of this angle alpha 1. You can also find out the angle theta from the Felenius chart, and then you can find out this center of location. So if the slope is up to 90 degree, it is very easy. If it is a toe failure, you can make use of the Felenius chart, and you can always locate the center of rotation. In the last video, I have told you that if it is a toe failure, then Felenius has given you, for the given beta angle, slope angle, the value alpha 1. So this is the alpha 1. Directional angles at A and at B, you can have the directional angles alpha 2, and therefore you know the center of rotation, O. So you can also get up to 53 degree. If it is more than, the angle beta is more than 53 degree, then you can get the value of alpha 1, and you can also get another value from the chart that is called theta. So you can make 2 theta here. So this line is known to you, and taking 2 theta as the angle, you can draw the slip circle. So Felenius chart is very, very important, be it toe failure, be it base failure. So for base failure, the method is quite simple, and you can make use of it, and you can locate the center of rotation. So today our objective was to locate the center of rotation. For example, let's say the values are like this. Say the beta slope angle is 40 degree. So for example, let's have angle beta, that is the slope angle, equal to 40 degree. So slope angle is known to you. And the height of the slope, h, equal to say 5 meter. And the depth, d, this value, let's say it is 7.5 meter. So this is going to be 2.5 meter below this. So total D equal to 7.5 meter. Now you can easily find out the depth factor. Therefore, you can calculate the depth factor ND, which is equal to, you all know, it is going to be D upon H. So friends, please calculate the value of depth factor. So this is going to be D upon H. That means 7.5 divided by 5, and this comes out to be 1.5. Now ND is known and slope angle is known. So once you know the slope angle beta, which is angle beta, this is 40 degree, and ND is 1.5, you can find out the value of Nx, that is the distance factor. So Nx value from the chart is very simple to find out because the charts is already given, and this comes out to be 0.8. So these charts are given by Felenius, quite useful. So I am able to find out for the given data the value of Nx from the chart, and therefore Nx equal to, as you know, the value of Nx, what it is known to all of you, is going to be now x divided by h. Depth factor is d divided by h, and the distance factor is x divided by h. Now this is already known to me as 0.8 multiplied by h equal to x. Therefore, x equal to, you can say 0.8 multiplied by 5. So this is going to be the value, that is 0.8 into 5, that is 4 meter. So this value from E to A, therefore EA equal to 4 meter. This value is going to be 4 meter if slope angle is 40 degree, height of the slope is 5 meter, and depth is 7.5 meter. Make use of Fellenius chart and find out the value of Nx, and then you can find out the value of x. So once EA is fixed, point E is fixed, this is already known to you because depth is fixed. Now on the vertical passing through the midpoint of the slope, you will have to see that whatever trial slip circle you are drawing from E is going to be tangent to this firm base. If it is not, just take the center of rotation either up or down, but it should be on the vertical. So this is the vertical passing through M, either up and down, such that whichever slip circle is drawn from the center of rotation, taking the radius as OE, is going to be tangent to the firm base. So this is how you can locate the center of rotation for a slip circle. For today, I wanted to do this much. In the next video, we will be able to do further. So thank you very much.